Dairy industry organisations and businesses have joined forces under a primary growth partnership project to produce a more efficient dairy cow. The large-scale study involving DairyNZ, LIC and Ambreed is now underway to try to identify a feed conversion efficiency breeding value. The work has the potential to generate significantly better production from individual cows, resulting in maximum performance from each unit of feed given.
This is the residual feed intake trial, trying to identify those animals that actually eat less than you think based on their live weight, their growth. So those ones that are more efficient at converting that feed into product. It enables farmers to feed the animals less for the same amount of output. So obviously there's profitability gains from that. Every kilogram of feed costs the farmer roughly 30 cents. So every kg that they can save from that is 30 cents saved in that. So these animals here, you're looking at trying to save, say, half of kg of feed because they are more efficient. So that translates into roughly 15 cents per day in saving. We've been working very much with the breeding companies to identify the bulls of interest. We've also working with our own DairyNZ staff, ag research as well for some of the testing protocols, and all funded by this primary growth partnership, which enables it to occur. In terms of where we're at with the current trial, we have two groups of animals that have gone through these facilities. So the first group was around 40 bulls and 160 heifers, and then the second group is slightly less numbers just to finish off the trials.
Feed efficiency is the all-encompassing thing, but residual feed intake is the difference between what you would expect an animal to eat and what they actually eat. And what you would expect it to eat is you'd use the live weight of the animal and the live weight gain, go back to standard tables and how much they would require for that growth. Similar work to this has been done over a number of years with chickens and with pigs. Tremendous amount of gain in terms of how much feed they need to offer chickens for growth, and the same for pigs. It's probably been used to a lesser extent in beef cattle, and really this is one of the first attempts with dairy cattle. Generally, when you're looking at mature cattle, lactating dairy cattle, there's a lot happening. So there's a lot of live weight gain, a lot of loss during lactation. So it's very hard to measure. With beef cattle, chickens or pigs, all you're looking at is live weight gain, so it's much easier to measure. We've used 10 sires that are in high usage throughout the country, and we've selected progeny from them, so heifers and bull calves from them. This work continues on from earlier work we did here with calves, where we put about 1,050 calves through, and we found the extremes, most efficient and least efficient. There was a difference of about 20% in intake. An Australian group did the work at the same time as us and got almost identical results. If we can identify that it is heritable, it will mean that the AI cooperatives will be able to measure efficiency or residual feed intake within their young bulls before they go into their progeny testing teams. We're after a marker, but also there may be other things that we may be able to measure, like heat loss. There are some indications that the most efficient animals lose less heat. So we are photographing some of the calves with a thermo-image camera to measure heat loss, particularly around the eye and the muzzle. They're in the facility for about 45 days, and there'll be about 38 days of measurement. So they're in there for a period of 7 days where they're just getting used to the facilities. In the previous work with just heifers, the most efficient calves ate about 10% less than the average, and the least efficient calves about 10% more than the average of the group. So when you extrapolate that out, that's about 20% difference between the two extremes in intake. If we can get the similar differences here with the bulls and the heifers, and we can identify heritable traits from that, it'll be very good for us. What we're looking at here is real-time information about what's happening out in the pens. So the calves' EID is being read, the weigh scales are giving us information on how much is eaten, and it's coming back here. So here we've got the EID of the calf for the individual bins, the scale weight, and down here we have the amount of feed that each calf has eaten. The value of this information, because it's real time, this means that we can look at the data and find out whether the animals are eating at different times of the day, so we can also look at behavioural aspects. So they're being ad-lib fed, but are some of them being forced to eat only at night or something like that when the other calves aren't eating? We can't feed pasture because it's not consistently the same over a period of time, where you can harvest lucerne and it is consistent. This is crucial because we need a consistent feed. It's easy to feed out and it stays the same dry matter percent. So if you use pasture, it changes in dry matter percent. It's just sitting in the bin. It drops away, moisture dissipates out of it. We're sourcing this from Australia, and it needs to be in cubes rather than pellets because we need a reasonable amount of fibre length, otherwise we get rumen acidosis with the calves.
There's a lot of international work as well in this area. So in Australia, they've also been pursuing residual feed intake trait. In Europe and the States, it's very much a hot area around the world now because it's the last bastion to try and understand in these animals in the future. And there's certainly interest in the beef sector. Any animal that can produce more meat from less feed is obviously a benefit of that. So we're working with beef and lamb to extend it. Our limit though is the farm gate, the dairy farmer's farm gate, but certainly I know there's trials that are going in the sheep sector and the beef sector. The ultimate aim is to have a feed conversion efficiency breeding value, so inherent efficiency, and then that information then being used in the breeding worth calculation, so an additional trait to be used in there. And we've estimated that that this could be worth, say, 5 to 10 million to the industry per annum just by selecting for this trait.
This program was made with funding from New Zealand On Air.